hopefully you went ahead and did that and found the C in the interval, which satisfies the mean value theorem of differentiation for this K of X on the closed interval from -1 to +1. If you have not, push pause and do that right now. Let's go ahead and solve this algebraically. K of X here is x to the third minus 10x plus 7. So we want to find the average rate of change. That's going to be difference in y values. Let's plug in 1 into the function k and then subtract what we get when we plug in -1 into the function k. The denominator in the average rate of change is going to be 1 minus -1. If you plug in a +1 into your function k, 1 cubed minus 10 times 1 plus 7 becomes -2. If I plug in -1 into my function k, I end up with -1 to the third power minus 10 times -1 plus 7, and that is 16. So my numerator is -2 minus +16. My denominator is 2. So we get -18 divided by 2, which is -9. So the average rate of change on the closed interval from -1 to +1 is -9. We want to find the value of x, whose instantaneous rate of change is -9. Take the derivative of k of x. The derivative is 3x squared minus 10. We can set that equal to -9 and then solve for x. Adding 10 to both sides produces 1 equals 3x squared. Divide by 3, 1/3 equals x squared. Take a square root of both sides. You end up with two values. One is the square root of 1/3. The other value is negative square root of 1/3. If you'd rather take the square root of 1/3 as a decimal or a rounded version of a decimal, it's right about 0.577. So if you wanted to write that as 0.577 rounded to 3 places, or this one as -0.577 rounded to 3 places, you could. Notice that both of these values are in the interval from -1 to +1. Therefore, in this case, we have actually two values of x which satisfy the mean value theorem. Again, that's perfectly plausible and perfectly possible and happens a number of times. So it is to be expected that certain times multiple values of x will all satisfy that mean value theorem simultaneously. And that is how you do this problem. By the way, as a side note, if you're plugging things into Moodle and there are two values that work, then there should be two value inputs into the Moodle problem. In other words, two answer slots if there are two answers that work.